right, let's get into it. Today, we're tearing down the architecture of a production-ready AI coding agent called OpenDev. And if you're a tech leader or an engineering manager, you're going to want to pay close attention. Think of this as your practical blueprint for building a truly autonomous copilot for your team, one that goes way beyond simple code completion. So let's pull back the curtain and see how it's actually done. You know, this quote from the source material absolutely nails it. We're in the middle of a huge shift in how we think about AI in development. And this isn't just about another cool feature, it's a completely new paradigm. We're moving away from tools that just help us inside an IDE to autonomous agents that can actually act for us right there in the terminal. And that one little change, well, it changes everything. So that brings us to the big question. Why does this terminal takeover matter so much? Well, for you and your development teams, this is both a massive opportunity and, let's be honest, a new strategic challenge. Let's break down what this move to the command line really means. Think about it this way. On one side, you've got your familiar IDE plugins. They're basically reactive copilots. They wait for you to type, then they suggest something. But on the other side, you've got these terminal agents. These things are autonomous actors. They can tackle long, complicated tasks, like refactoring a whole module or debugging some gnarly issue, all on their own. Now, as a manager, here's the part you need to hear. All that new power comes with new risks. We're talking cost, safety, and scalability. And you absolutely must have a plan for it. So here's the game plan for this explainer. We're going to start with the architectural blueprint. Then we'll dive into the big one, safety. After that, performance and long-term maintenance. And finally, we'll wrap it all up with some real actionable lessons for your team. Okay, let's get right into the nuts and bolts. You know, at the heart of any AI agent that's actually stable and can scale is a rock-solid foundation. OpenDev organizes this into a really clean 4-layer architecture. Okay, I know this diagram is a lot to take in at first, but don't worry, we're going to break it all down. For now, just follow the arrows. Over on the far left, you've got the entry and UI layer. That's how the user talks to it. That input flows through the agent and tool layers in the middle. That's where all the thinking and doing happens, and it all ends up in the persistence layer on the right, which is basically the system's memory. The key takeaway here, and every manager loves this, is the clear separation of concerns. Let's make this even simpler. So let's just boil it down. The entry and UI layer, that's the doorway. It's how the user gets in. The agent layer is the brains, doing all the reasoning and making decisions. The tool and context layer, those are the hands, executing commands and grabbing info. And finally, the persistence layer is the memory, saving everything. Doorway, brains, hands, and memory. Simple, right? But incredibly effective. Now, this is a really crucial design lesson. OpenDev splits its work into two phases, what they call scaffolding and the harness. Think of scaffolding like all the prep work a chef does before the restaurant opens, chopping vegetables, making sauces. The harness is the actual cooking during the dinner rush. By doing all the assembly up front, they call it eager construction, the system gets rid of that annoying lag on your very first command. It's ready to go instantly, and that makes for a way better user experience. Okay, this is the section every single engineering manager is thinking about. How in the world do you give an AI agent the power to run shell commands without it, accidentally deleting your entire production database? This part is all about building safety that enables powerful actions instead of just handcuffing the agent. And here's their really elegant solution. The whole system runs in two different modes. When a big complex task comes in, it kicks into plan mode. And in this mode, the agent is totally restricted. It can only use read-only tools. It can look around the codebase, analyze files, and come up with a detailed step-by-step plan. Only after a human developer looks at that plan and says, okay, looks good, does the system switch to normal mode, where the agent has full access to actually execute those steps. It literally thinks before it acts. And to make this even safer, the planning part is handed off to a specialized planner sub-agent. As you can see, this little sub-agent is completely isolated. It only has read-only tools, so it is physically incapable of making dangerous changes. The main agent is the one that gets the keys to the car, but only to follow a map that's already been vetted by a human. This separation of duties is such a powerful pattern for building safe and predictable systems. But they don't stop there. OpenDev uses what's called a defense-in-depth strategy. We're looking at 5 totally independent layers of safety, from high-level prompt guardrails all the way down to low-level system hooks. The whole idea is that there's no single point of failure. If one layer somehow gets bypassed, there are still 4 others standing by to catch a dangerous operation before it happens. Let's compare 2 of these safety mechanisms because it really shows why this is so effective. A runtime veto is reactive. It's like a bouncer stopping a dangerous command at the very last second. But schema filtering is proactive. For that planner agent we just talked about, dangerous tools like write file aren't just blocked, they literally don't even exist in its reality. The agent never even sees the tool. It's a much, much more robust way to enforce safety. So we've built a safe foundation. Now let's talk about performance, because a super powerful agent is pretty useless if it's too slow or costs an arm and a leg to run. And that brings us to 3 of every manager's favorite words: smarter, faster, and cheaper. This diagram shows off a brilliant cost-saving strategy. See, OpenDev is built as a compound AI system. So instead of using one giant expensive model for every single thing, it has a whole pool of different LLMs to choose from. It can route simple tasks like summarizing a file to a small, cheap, and fast model. And it saves the big, powerful, expensive models for the really complex stuff, like planning. This is an absolute game changer for managing your operational costs at scale. We mentioned this a bit earlier, but it's such a critical performance lesson. The old way, lazy prompts building, meant the system would wait until the very first command was issued to assemble the agent. And this caused a really noticeable lag that just kills the user experience. The new way, eager construction, builds everything when the system starts up. The result? 0 first call latency. It's a pretty simple design pivot that makes a huge difference in how responsive the tool feels. You know, one of the biggest technical hurdles for any agent is that finite context window. So here are 3 really clever ways OpenDev deals with it. Adaptive compaction intelligently summarizes older parts of the conversation to save space. Cross-session memory lets the agent actually learn about your specific project over time. And event-driven reminders are like little nudges to keep the agent from forgetting what it was supposed to do on a really long task. Here, context engineering is a first-class concern, not an afterthought. A successful system isn't just about what it does today, it's about how easily it can grow tomorrow. So this section is all about building a future-proof architecture that doesn't become a maintenance nightmare for your team down the road. Here are 3 really powerful patterns for making a system extensible. Lazy tool discovery means the agent only loads the tools it actually needs, right when it needs them. This alone cuts down the initial context load by over 80%. The skill system lets anyone on your team add new reusable prompt templates without having to change any code. And refactoring to a single agent class? That's a classic engineering win. It simplifies the whole code base, making it dramatically easier to maintain and build on top of. Whew, okay, we've covered a ton of ground here, from high-level architecture all the way down to low-level optimizations. So let's try to boil all of this down into some core lessons that you can take right back to your own teams. This is just a fantastic, practical piece of advice. Let's face it, LLMs can be imprecise. A really strict tool might just fail if the agent tries to edit a line of code but gets a single space wrong. A well-designed tool, though, absorbs that imprecision. It understands the agent's intent, finds the near miss, and turns what would have been a failure into a success. Your tool should be built to bridge that gap, not just reject every imperfect attempt. And here it is, the cardinal rule for system stability, especially for agents that have to run for a long time. Any resource that grows over time, we're talking the agent's iteration count, its undo history, anything like that, it must have a limit. Unbounded growth is the silent killer of stable systems. It's a simple rule, but it is absolutely critical for building a robust agent that can run for hours without falling over. And that leaves us with one final question for you to think about. As you start to bring more advanced AI into your own workflows, take a really hard look at the foundation you're building on. Is it a thoughtful, robust blueprint like the one we've just explored? Or is it kind of built on hope? Because the choice you make there will define its success. Thanks for joining me.
Please like, share, and subscribe.